Our third shuffle for today is the Klondike shuffle. So let me show you how that shuffle is performed. So this is shuffle number 15. So if we begin with our ordered packet 1 through 8, we perform the Klondike shuffle and then we record the new ordering of the cards. So the way that the Klondike shuffle works is you take the bottom card, just one, and the top card, just one, off as a pair. Okay, and you just set that down. So bottom and top together as one, bottom and top together as one, and then we only have 2 left. Set those on top. So what is the new ordering after the Klondike shuffle has been performed? Well, it's as follows. It's 4, 5, 3, 6, 2, 7, 1, 8. So that is why when we write out the Cauchy two-line notation for this permutation, we get the following: 4, 5, 3, 6, 2, 7, 1, 8. We can convert that to cycle notation as follows. So here we see that 1 is sent to 4. So 1 goes to 4. 4 is sent to 6. So 4 goes to 6. 6 goes to 7. So we have an arrow from 6 to 7. And then 7 goes to 1, which wraps around. So that completes that 4 cycle. We also get a transposition, since 2 goes to 5, so 2 goes to 5, and then 5 goes back to 2, so it wraps around. So we get this 2 cycle, also called a transposition. And I apologize, for some reason I originally left off what happens to 3 and 8. So 3 is a fixed point, 3 goes to 3, and 8 is also a fixed point. What starts in those 2 positions will be returned to those positions. Okay, so we do get 2 single cycles here. Now if we color code our cycle notation of the permutation, we get the following. So we get 1, 4, 6, 7. Now remember, all of those are color coded black. And then we get transposition 2, 5. And those values are color coded red. And we also get these 2 single cycles, which ordinarily are not included in the cycle notation of a permutation, as long as you're clear on how many elements there are in the set that you're working with. Okay, so we can readily see what's happening here is that each value gets sent to a value of the same color. So in other words, inversion does not occur here. So what it means then is the cards in positions 1, 4, 6, 7 stay somewhere within those positions after the Klondike shuffle is performed, and cards originally in positions 2, 3, 5, 8 stay somewhere in those positions. And then we have this situation down here where the form of the Bessey sequence is preserved. So no inversion here. In fact, why don't we quickly demonstrate that? So if we begin with the Bessey sequence 1, 0, 0, 1, 0, 1, 1, 0. If we perform this shuffle, we will get back that form. So the Klondike, top and bottom come off as 1, top and bottom come off as 1, top and bottom, and then the last 2 go on top. So what we should get back is 1, 0, 0, 1, 0, 1, 1, 0. And that's exactly what we get back. Now we need to realize that the cards labeled 1 here are moving around among themselves. They really are switching places. And the cards labeled 0s are also moving around themselves, with 2 exceptions. The 0 right here in position 3 will stay right there. It will be returned to position 3 after the Klondike shuffle has been completed. Also, the 0 in position 8 down here will be returned to position 8. And that's because those are fixed points. So if we step through the construction of the Bessey shuffle diagram for the Klondike shuffle, we get the following. So recall, 1 goes to 4, 4 goes to 6, 6 goes to 7, and then 7 goes to 1. We'll just check that. So we have 1 here. It goes down to 4. So we have an arrow from 1 to 4. And then 4 goes up to 6. And then 6 is sent to 7. so it goes straight up. And then 7 is sent back to 1, so that completes that cycle. So we would say that the values 1, 4, 6, 7 constitute one of the orbits for this shuffle. So those values just get moved around among themselves according to the arrows indicated on our Bessey diagram. And then for 2 and 5, which form a transposition, this means that if we start at 2, it's sent down to 5, and then 5 is sent back to 2. So that's why we have a double arrow between 2 and 5. And so since inversion does not occur, that can be summarized as follows right here. And I thought it might be helpful to note that this shuffle here is actually the inverse of one that we've seen, namely shuffle 12. Now once you know this, you can use this pair of shuffles to ostensibly mix the cards, but in the end you're leaving the cards exactly where they started. So let me remind you of what shuffle 12 was. So here is shuffle 12. It's the mange shuffle. In particular, it's the under-over. So what this will mean then, if you perform the Klondike and follow that with the mange under-over, it will reset the packet to its original order. Or if you originally mange shuffle the packet of the under-over variety and follow that up with the Klondike, you will also return the packet to its original order. And we can see that they're inverses by the fact that the diagrams for the Klondike and for the mange under-over are identical, except for the fact that the arrows have been reversed. Okay?